Object-oriented programming with C++. Object-oriented programming may be defined by its three fundamental characteristics: encapsulation, inheritance and polymorphism. This tutorial introduces object-oriented programming by introducing encapsulation. We use C++. Assume that a program requires the calculation of the area for various geometric shapes, for example, circle, triangle, orthogonal. According to the methodology of procedural programming, suitable procedures, also called functions, should be defined, one for each shape. For example, orthogonal area is a function. It receives two double parameters. The first represents the height of an orthogonal, the second the width, and returns a double that represents the area. Similarly, circle area calculates the area having as input the radius. It also uses pi constant, which is equal to 3.14159222654. Finally, triangle area also receives two double parameters, representing height and width accordingly. Given the aforementioned definitions, the actual calculation takes place when a corresponding function is called. For example, the function usage below. Suppose we have two double variables that represent the height and width of an orthogonal. We can calculate the area by calling the function oblong area. Similarly, if we have a circle of radius r equals 5, for example, the area of the circle, we can estimate by calling the corresponding function. Finally, we have two double variables that represent the height and width of a right triangle. Then, we can calculate and display the area of the triangle by calling the function triangle area, for this height and this width. A major disadvantage of procedural programming is the separation between data and functions operating on that data. Looking back in our example, we note that function circle area requires the radius of a circle as to calculate the area of the circle. The radius of circle is given to circle area through the formal parameter radius, which is double. Therefore, compiler knows and checks the type of the actual parameter, which should be also a double. Otherwise, compiler produces a compile time error. Therefore, important errors may be avoided. This is known as type checking. Despite its usefulness, the type checking mechanism does not cover cases where an actual parameter has the right type but carries erroneous information. For example, assume that function circle area is called with a double parameter that represents the height of a triangle. Although the type is correct, the actual value is probably erroneous. Therefore, invocation of circle area constitutes a logical error. However, such an error is not detectable by the compiler in the context of procedural programming. This is a fundamental problem that is solved by object-oriented programming with encapsulation. According to encapsulation, data and functions are bundled together in the same entity, which is called an object. For example, we may define an object representing a triangle that encapsulates the calculation of the area and its characteristics height and width. In order to define such an object, we should first define its type. Object's type is referred as class, for example, class of triangles, class of circles, etc. Each declaration within the block of a class defines a class member. Thus, class triangle encapsulates three members: height, width and area. Therefore, members of a class are divided in data members and function members, which are also called methods. Given the definition of class triangle, we may declare objects as follows. Note that a specific object occupies corresponding location in memory, called instance. Often the terms object and instance are used alternatively to indicate the same concept. Rather, two references to the same object are two distinct object instances. Thus, the concept instance refers more to the variable associated with an object. Finally, note that the method area does not accept parameters, instead acting to the member's data of class.